So in our previous video, we designed a finite state machine for a sequence detector that would detect the sequence 1011 for a case where the sequence did not reset and the case where the sequence did reset. And we designed a Moore type machine because it only had a Moore output and no Mealy outputs. So now we want to do this again, looking for the sequence 1011 using a Mealy machine. So let's go ahead and start with our state legend, or our state diagram legend. So we're going to have the state. There's going to be no Moore output in this case, and we're going to have input X and output Mealy output Z. So we're going to start by drawing the state diagram for the sequence detection. So we're going to have AB. Remember, we're looking for 1011. So if we get a 1, we're going to transition to B and have no output. If we get a 0, we're going to get 1 0. Still no output. D, getting to D, we have a 1 0 1. Still no output. And now, if we are doing the reset case, so reset case I'm going to have in this color here, we are going to go back to A if we get a 1, and we're going to get an output of 1. So here you see we have 1 0 1 1, and the output happens on the transition. So what's different about the Mealy and the Moore machine versions is that the Mealy machine has one less state than the Moore machine because we needed a whole state to represent the output. So if you remember from our Moore machine, we had state E had our detected output. Whereas now in the Mealy type machine, we don't need a state to represent the output. The output can happen on the transition. So we got the sequence 1011 after we transition from D to A. So why is this the reset case? Well, let's again look at where we are at in each of these states. So to get to A, we only had a 0. To get to B, we got a 1. To get to C, we had a 1 0. To get to D, we had a 1 0 1. So if we got another 1 and transitioned back to A, that means we would have had a 1 0 1 1. We would have had a detection. Now we reset back to state A because in order to get another detection, we're going to have to get another 1 to start the new detection off. However, in the non-reset case, which I'll put in orange, non-reset, here we had a 1 0 1. Now if we had another 1, we're going to end up back here. And why is that the case? Because what would happen is, I guess I'll put this in the dark blue, is if we got a 1 0 1 and then had another 1, 1 0 1 and had another 1, and then we got a 0 1 1 again, we would have two detections because this would be a detection and this would be a detection because we didn't have to reset. We didn't need a new 1 to start this again. Alright, so now let's go back and just fill in the rest. It's going to be the same for both the reset and the non-reset case. So in A, we already took care of the x equals 1 condition. So the x equals 0 condition will keep us in A and have no output. All of these are going to all have no output now because we took care of the output condition where we detect our sequence. Alright, so in B, we have our 0 case. If we get another 1, we're going to stay in B. So it's going to be a 1, no output. In C, we got here by having a 1 0. If we get a 1, we already know we're going to D. If we get a 0, we need to reset because then we would have a 1 0 0, which doesn't lead us towards our sequence, so we need to start over again. So 0, 0. And D, we already know what happens if we get a 1. In either the reset or the non-reset case. What happens if we get a 0? If we get a 0, we got to D by having a 1, 0, 1. So if we get a 0, that means we want to go to the state that represented our 1, 0, because that's what we would have right here. So then this transition is a 0, 0 for both the reset or non-reset cases. So there you have it. This is now our Mealy design for the sequence detection of 1011. And again, you could go through and pick a random sequence to test out your design to see if you're getting a detection when you expect to detect one.